Hello everyone, my name is Subhalakshmi Raut from Ambika Prasad Research Foundation, India, and today we are going to continue our UGC NET classes of environmental science on second unit environmental chemistry, and today we will continue our part 2 session, and we are going to study on classification of elements. What is an element? Generally, element is a pure substance that is made up of only one kind of atom. Maybe they have the same number of protons or not, but it is the pure substance, means the simplest substance, which cannot be broken down into any other substances. And for example, iron. Iron is made up of iron atoms only, and silver is made up of silver atoms. So elements are the substances that cannot be changed by chemical reactions, but new elements can be formed by nuclear reactions. Next is, what is an atom? Elements are made up of atoms, means atoms are part of the elements, but what are atoms? Atoms are the fundamental building blocks of all matter. Maybe it's solid, liquid, or gaseous in um, state, and they are the smallest indivisible particles of matter. And atom also can neither be created nor destroyed. And atom as a whole is electrically neutral. That means it is made up of protons and neutrons. Protons are positively charged and electrons are negatively charged, and neutrons are neutral in charge. So on a whole, atom is electrically neutral. And atoms are composed of three fundamental particles, namely protons, neutrons, and electrons. And atom is the Greek word atomio, which means uncuttable. That means it is the simplest and smallest undivisible particle. Now we will study about some discoveries. It is discovery of electron. It was done by J.J. Thomson in 1897. He used Faraday's study of electrical discharge in cathode ray tubes experiment to prove his discovery. And cathode ray tube is a cylindrical tube where two oppositely where two electrodes are connected to the two oppositely charged poles and of a battery. Then he passed the gas inside the tube, which is subjected to very low pressure and very high voltage. Uh, and when the current is let pass through the tube, then we can he could see that a stream of particles moving from cathode, that is negative electrode, to anode, that is positive electrode. So he named those streams of particles cathode rays. And further in the future, we came to know about those cathode rays as electrons. So next one is proton, and uh, Goldstein um, discovered this particle, proton, on the basis of the same cathode ray experiment by slightly changing it by using perforated cathode. He suggested that as an atom is wholly electrically neutral, so if negatively charged electrons are present in an atom, so there must be some positively charged particles. So when he did the same experiment, the cathode ray tube experiment, using perforated cathode, he found that um, some rays were found to originate from anode, and these were known as anode rays or canal rays, as it passes through the perforated tube cathode. and those stream of positively charged particles were when were protons. When hydrogen gas was taken inside the cathode ray tube, then the hydrogen atoms split into H plus ion and electrons. So the H plus is the proton. Then the next one is neutron. Neutron was discovered by Chadwick in 1932, and when he bombarded a thin sheet of beryllium by alpha particle, that is helium, then the electrically neutral particles having a mass slightly greater than protons emitted. So he named those particles as neutrons. And here we can see the some characters of these particles. Proton is generally found inside the nucleus, and neutron also inside the nucleus, and electron revolves around the nucleus. And the charge is in proton is plus 1.602 into 10 to the minus 19, and neutron is of zero charge, and electron is minus 1.602 into 10 to the minus 19 coulomb. And here we can see the masses also. The heaviest one is neutron. And now we will learn about how to write an atomic formula or elemental formula. Uh, Here we can see that X, A, Z. So X represents the chemical symbol of the element, A represents the mass number, and Z represents the atomic number. Here atomic number is basically number of protons in the atom, and mass number is the summation of atomic number, that is number of protons plus number of neutrons. For example, if we want to write the formula of an element, like if we consider oxygen, here in the place of X we will write O. O is the symbol of oxygen, and in the place of Z we will write the atomic number, that is number of protons present, that is 8. So in the place of XO, Z8, and mass number, which is summation of number of protons and neutrons. So the number of protons is 8, and number of neutrons is also 8. So the mass number will be 16. So the formula of oxygen will be O in the place of Z 8, and in the place of A 16. Now, what is the difference between atoms and elements? There is the basic difference that element is the simplest form of a substance, and atom is the part of an element. For example, in this diagram, you can see the um, representation of oxygen atom. Here, you can see the protons, neutrons, and electrons. But in the element, here gold, it represents that um, it is the simplest form, and the atomic number is 79, and neutrons is 118 neutrons. And normally element is composed of only one type of atom, and here in atoms it consists of electrons, protons, and neutrons. Elements can combine with each other to form molecules via chemical reaction, but in the case of atoms, it can also combine to form electromolecules. But if all bound atoms are of similar type, then we can call it elements. And elements are generally bigger and heavier, but atoms are very tiny particles, and Till now, there are total of 118 elements and 92 kind of atoms. And we studied about elements. But now come to think about why we need to classify these elements. Generally, classification makes our work easy to study the properties. So these are some points to say that why we need classification of elements. So in chemistry, there are a large number of elements that have been discovered. From 1800, there were only 31 elements, but now, presently, we know about 118 elements. And out of 118 elements, 94 elements are naturally occurring and the rest are man-made. So can you see this big number of elements? How can we study each and every one? So if we classify them according to their physical or chemical properties, then we can study them as a group. So we can easily study them. And therefore the elements are arranged in a systematic manner according to their properties. Classification also helps us to understand the properties of elements and their compounds. Not only it helps to know about the properties of elements, but it also gives us idea about on which level the two elements will mix to form compounds or not. So based on their position in periodic table, we can also predict that the properties of their compounds. And if we get a unknown compound or unknown element, we can compare them to know about their, if we know about the properties, then we can also place them in a certain position also. So, and it is also easier to study, compare and differentiate the properties of elements and compounds from different groups. Now we have some classification types, like from starting how these scientists were classifying the elements. So first one and the simplest one is Dobener's law of triads. So he is a German scientist, Johann Dobrener, and in 1829 he gave his law about the triads, which states that if we take a group of three elements that mostly have similar characteristics, then we place them according to the increasing amount of atomic mass, then we will see that the atomic mass of the central element is the arithmetic mean of other two elements. Like for example, in this is the table that was given by Dobrener, and here he showed that lithium, sodium, and potassium all are arranged in increasing order of their atomic mass, and we can see that sodium has the atomic mass that is equal to the arithmetic mean of the first and third element. So, and the group of three elements were called triads. And actually, Dobrener was the first scientist to show some relationship, that to be clear relationship between the properties of an element and its atomic mass. But he could not completely present the idea of these elements. So the drawback of this classification is that his concept was applied to only limited number of elements, that is 9, and but there were so many elements in the nature. So that's why this theory was rejected. Next one is Newland's law of octaves. Here, the English scientist John Alexander Newland, in 1865, he classified the known elements in the increasing order of their atomic masses. So that, and and after arrangement, he noticed that every eighth element of the series means in the horizontal um way, that when the elements are arranged in the horizontal way, that is called series. So he saw that every eighth element of the series has the property similar to the first element, as like in our Indian classical music, uh, the every note resembles the first of the octave of music. So like the first element here is hydrogen, second lithium, third beryllium, fourth boron, fifth carbon, sixth nitrogen, seventh oxygen, and eighth one is fluorine. So here you can see that there are some properties, chemical properties that are similar between hydrogen and fluorine. But drawback to this system was that it only worked for lighter elements, that is up to calcium, and failed to show the relationship for heavier elements. And he created this table thinking that only 56 elements existed, but there were some new elements that are discovered that did not quite fit into this table, and in order to fit them in the table, he adjusted two elements in the same slot, which like cobalt and nickel in the same table, which is not correct. And he also put some unlike elements in the same slot. So due to this drawback, this classification system was also not accepted. Next one is Lothermeyer curve. Here, the German chemist Lothermeyer plotted a graph um, taking physical properties like atomic volume, melting point, boiling point, etc., against atomic weight. And he saw that there was a repetition of a pattern. He saw that there is an increase in atomic volume uh, at lithium, sodium, potassium, rubidium, cesium. So he concluded that they must have some equal properties, chemical properties. So he developed a table according to that closely resembles to the modern periodic table. But his work was not published until after the work of Dmitry Mendeleev. So this was not a complete. This was due to unfortunate accident, and the scientist that is Mendeleev, who is given the credit for the development of modern periodic table. In the Mendeleev's periodic table, Mendeleev was close to giving the correct form of table, and he suggested that the properties of elements are a periodic function of their atomic weights. This means that the chemical and physical properties of the elements reoccur periodically when the elements are arranged in the order of their atomic weights. Here in the table, you can see that um, the after placement of hydrogen, there was placement of lithium, sodium, potassium, copper, rubidium, silver, cesium, gold in the same line. That means that he arranged this table according to the atomic weight, and he saw that the first um, group, that is group 1, has similar um, physical properties or chemical properties. And Mendeleev arranged about 63 elements in horizontal rows and vertical columns, and um, the periodic table of Mendeleev has 12 horizontal rows and known as series, and the series were further divided into horizontal columns known as groups. He actually relied on the similarities in the empirical formulas and properties of compounds formed by the elements, but he quickly realized that some of the elements did not fit to his scheme of classification. So, so he violated his own periodic law, and there were some drawbacks of his table. That is, he could not explain the position of hydrogen in the periodic table, and there were also no place for isotopes of elements in the table, and the increasing order of atomic mass could not be maintained in this table, and there was wrong placement of some elements, like iodine had lower atomic mass than tellurium but was placed ahead of tellurium because iodine shows similar properties with fluorine and bromine, and he there was some advantage, like he knew that he left some elements that were still undiscovered, so he left some gaps for the unknown elements, and he placed them according to the properties of the previous elements. Like for gallium, he left the place as Eka aluminum. For germanium, he left the place as Eka silicon. Now, this is the final and accepted modern periodic table, and it took a very long time to uh, make it perfect. And here, it is the long form of periodic table of elements, and it is based on the Bohr-Curie concept of electronic configuration. And in this periodic table, uh, there are some silent features, like it contains 7 horizontal rows called periods and 18 vertical columns called groups, and the elements with similar valence cell configuration are arranged in vertical columns referred to as families or groups, like um, lithium, sodium, potassium, rubidium, cesium, and francium are placed in first group because they have only one electron in their last cell. Valence means last cell, and each period corresponds to the highest principal quantum number of the elements in the period. That means that in the first period, here only the first cell like K shell consists only two elements, and subsequently when the periods increase, so the cell number of atoms in the cell will also increase, like electrons in the cell will increase, like 8, 18, 32. In case shell has 2 electrons, L will have 8, M will have 18, and N will have 32 electrons. But the seventh period is considered incomplete because theoretically it can contain 32 elements, and 14 elements of both sixth and seventh periods, that is lanthanoids and actinoids, are placed in separate panels at the bottom. So this explains the positioning of every element in the periodic table without any drawbacks. So this is the most accepted theory of periodic classification of elements. Thank you.